Today we're starting Unit 8. It is our polynomial unit. We did a lot of this stuff with polynomials in our Unit 7, so hopefully at least the front page is review, and then the back page may or may not be familiar from Algebra 2. But what it is that we're going to do today is our basic operations of polynomials. Operations, mathematical operations, are addition, subtraction, multiplication, and division. So we're going to start on the front with addition, subtraction, and multiplication, and then the back will focus on the division because that's the harder part out of this. So here is what exponents must entail. Exponents, in a polynomial, all the exponents must be a whole number. So it can't have, say, x to the 1/2. That's not a whole number. That would not be a polynomial. So for polynomials, you will only see whole number exponents. No variable would be in the denominator. We saw a lot of this when we were talking about domain, and we would do 1 over x plus 6, and then we'd say x plus 6 can't be 0 because that would be undefined. We're not going to worry about that because just by definition of polynomials, all the x's will be in the numerator. And then no variable is under a radical. If you remember from Algebra 2, this third and first criteria are really saying the same thing. If you know what I'm talking about, then you are really ahead of the game. But what I'm talking about is if you had, say, the square root of x. In Algebra 2, we taught you how if you're talking about a square root, there's the invisible 2 right here. You don't usually write square root. And then the exponent here is a 1. And we would practice converting this to exponential form, which would be x to the 1/2. If you don't remember that, this is not what we're focusing on right now. I'm just trying to show you that this third thing and this first thing are really the same thing, because this is showing the third thing. It's not allowed to be in a radical, but this is showing a fractional exponent, which is not allowed either. So just when you're looking at polynomials, they should appear fairly normal. They may look a little bit different, but for the most part, these should be normal looking things. Okay, so let's talk about some terms that I'm going to use. I'm going to use the term degree often, leading coefficient often, and constant term is really hopefully not something new. Constant just means it doesn't change. So the degree of a polynomial. The degree of a polynomial is the exponent of highest power. So in a polynomial, you can see multiple exponents, but the exponent that has the highest whole number is going to be the degree. And in front of that exponent is going to be the leading coefficient. So these two things actually go together. Where you find the degree, you will also find the leading coefficient. And then the constant term is just the number that is all by itself. So let's say plane, the plane number. The reason why they call that the constant term, if you look in the first example, that plus 10 is always going to be plus 10. It doesn't matter what x is, you're always going to add a constant term of 10. So that's the constant term. It's just the number that's all by itself. So let's do the degree and the leading coefficient. So if I read the polynomial, it reads 6x to the 7th plus 4x cubed plus 5x squared minus 7x plus 10. If I look at all of the exponents, I have an exponent of 7, 3, 2, 1, you could say, and there's not an x, so not an exponent. So the highest exponent I see is 7. That is the degree. So the degree is 7. Then, when I say that these two things go together, it's because 6x to the 7th is that term. 7 is the degree, 6 is the coefficient of that degree. So really, you're kind of circling one part of that polynomial, and it takes up 2 places. Okay, so in the next one, we only have one term, so that 3 must be the highest degree. 3 is the highest degree. You could always stick a 1 in front of things for a coefficient of 1. And a constant term, you're not really adding a number. You could always say, well, I'm adding 0. So 0 is the constant term. This next one, in my opinion, is a little tricky because some people would argue that this is not a polynomial since it doesn't have an exponent at all. But you could always write plus 0x to the 0, and that's why I think that this is tricky, is because why on earth would you ever want to do that? I am not sure. But I think that's what it's wanting you to do. So the degree is 0, the leading coefficient is 0, and the constant term is 12. I would not put that on a test because in my opinion, that's not a polynomial. It's a constant only. So sometimes they don't ask for my opinion, though. All right, the next one reads 2x to the 6 plus 3x to the 7 minus x to the 8 minus 2x minus 4. So as I'm reading this, I notice the highest exponent is x to the 8. So 8 is the degree. It had a coefficient of -1, and the plane number is -4. Okay.
Why would your coefficient be -1?
Because I don't know what I'm doing here, but this is -x to the 8th is what I covered up here, right?
So wherever your highest exponent is your highest coefficient?
Is your leading coefficient. Because when we write polynomials, I personally would take the time to rewrite that example in descending order. And so if I put it in descending order, this would be the first thing that I would write out. So the leading coefficient is -1. That's why when we were doing stuff like that, I asked that you would put it in descending order. I didn't really say that it was a requirement, but it does make it nicer to look at it on the eyes. Okay. First degree polynomials are called linear functions. So, for example, 5x plus 1. If you were to graph that, you would be graphing a line. Second degree are called quadratics. Or quadratic functions. So an example is 2x squared plus x minus 1. Third degree are called your cubics. So 4x cubed minus 1. Fourth degree polynomials, honestly, I think there may be a name for it, but I don't even remember. I would never ask you that. At this point, I just start calling them fourth degree, or fifth degree, or sixth degree, so forth. I've never memorized the name for that. I think it's quartet or something that means more than one thing, so who cares? Okay, so x to the 4th is a very basic example of that. Okay, when we add or subtract polynomials, we combine like terms. If I could write in the blinks, I'd be writing this in the blinks. I'm not very good. So to add or subtract, you will combine like terms. Of course, when you end up subtracting is the harder, because if you end up subtracting right here, this negative sign needs to go to all 3 of these pieces. Therefore, I am going to take the time to distribute that negative sign and rewrite the problem. So when I rewrite the problem, this does not change. However, I will distribute the negative to all 3 of these pieces. So I'm just going to rewrite the beginning as negative 2x cubed plus x squared minus 4x plus 1. But then I distribute, so negative 2x cubed Negative negative makes plus x, negative 4, minus 4. And at this point, I will combine my like terms. So cubics, my cubes are negative 2x cubed minus 2x cubed makes total negative 4x cubed. My squares, I only have a single plus x squared. My x's, I have minus 4x plus x makes minus 3x. And 1 minus 4 is negative 3. Okay, hopefully all of this is a very quick review. Yes. Okay. For multiplying, we definitely just did some multiplying on the test. When you multiply, you will distribute or FOIL if you have to do more than one. Okay, so let's do A. If I'm going to do A, I have to do 3x squared times 5x cubed minus x squared minus 4x plus 2. So the 3 times the 5 make 15, but you also have to do x squared times x cubed. If you have x squared, you multiply times x cubed, x to the 5th. You're basically just adding the exponents. Okay, 3x squared times negative x squared is negative 3x to the 4th. 3x squared minus 4 makes minus 12x to the 3rd. And 3x squared times positive 2 makes plus 6x squared still. There are no like terms to combine, so that would be a final answer for that. Okay, everybody got that? Because I'm going to erase this. Okay. All right, in B now. B is going to be an example where I have to FOIL. 2x is going to multiply times 3x. 2x will also multiply 5. So 2x times 3x is 6x squared. 2x times 5 is plus 10x. Now I got to do the bottom. Minus 3x minus 5. I will combine my like terms. Here are my like terms to be a final answer of 6x squared plus 7x minus 5. Okay. And so our last question is going to be the hardest. It takes a lot of space, so. Now I have to do 2x times this piece, and this piece. Then I'll have to do negative 3 times this piece, and this piece. So let's do one time. 2x times x squared is 2x to the 3rd. 2x times 3x is plus 6x squared minus 10x minus 3x squared minus 9x plus 15. I will combine some like terms. It looks like this is my only cube, so 2x cubed stays. 6x squared minus 3x squared makes positive 3x squared. Negative 10 minus 9 makes negative 19. 15 is left by itself. So going back through those vocabulary terms we just talked about, you would say that this is a polynomial of degree 3, whose leading coefficient is 2, and constant term is 15. Okay? Okay, so the back. You're dividing. As you can see, can I make this smaller? I can. As you can see here, there are two different types of dividing. I don't like that. It's crooked. Okay, there are two different types of dividing. There's, is it not? Oh, there's long division, divide using long division, and there's dividing using synthetic division. Find a place to write this, because you're going to want to write this down. So long division is harder. But it makes sense. So, but logical. Also, long division you can always use. There's no rule for when you can and cannot use it. So, of course, the harder one is the one that you get to use anytime you want to. That's how it always goes, right? The synthetic division is much easier. Everyone loves synthetic division. However, it follows no logic. It is pure memorization. It is follow this step, step 1, step 2, step 3. And the other downside to it is that the divisor must be of degree 1. The divisor is the one that's on the bottom, yes. So if you look at example 3A, if you look at this example compared to this example, they are the same. They are the exact same numbers with the exact same divisor. They're showing you how if you use long division, you're going to get an answer. If you use synthetic division, you're going to get the same answer. Synthetic would be much easier. Yes, are y'all with me? Okay, in example B over here, this is an example where you could not use synthetic because of that 2x squared right there. This would not be an option of using synthetic. So that's the main difference between the two. Okay, y'all don't have to write this. I just want to go through. Okay. So I am going to take a lot of space. My advice to you is write small. I'm going to have to adjust this every time. Personally, I wish they had not wrote this out for you because the type is so small and your handwriting is going to be big. But the goal here is to make nice, pretty rows. Okay? It's difficult. It's going to be really difficult with this. Okay, so what we're going to do, keep that basic idea. I mean, it's obviously a little different because now it's with x's, but keep that basic idea in mind as to what it is that we did. So I'm going to start. I like to put parentheses here. I think it's helpful. It reminds me that I will multiply not just by x, but by the -2 as well. We start here, and you're just going to be concerned with the x, and the 2 will just follow along with the formula, okay? So what times x gets you 3x to the 4th? 3x to the 3rd. If you want to write a little 1 right here, that's fine, because the 3 times the 1 get you this 3. The x cubed times the x gets you the x to the 4th. So that's what you're going to do now, is you're going to multiply this 3x to the 3rd times the x, but also times the -2. So 3x to the 3rd times x gets you that 3x to the 4th that you wanted. 3x to the 3rd times -2, however, gets you -6x cubed. And I am really, really sorry, I forgot to mention this. Notice that they inserted a 0x cubed because if you look at the original problem, they didn't have an x cubed there. So when I was talking about getting those nice pretty rows, they wanted to include the cubic row. So they inserted 0x cubed. That is really, really important to do. Okay, so your first mental check is, okay, I start with a degree of 4, then I need to see the 3, so that's why they inserted it, the 2, the 1, the nothing. Okay, and we will do that again before the day's up. All right, go back to what we did when we were dividing. After you multiplied, then you subtracted. When you subtract, though, we just practiced subtracting. You do need to subtract the entire thing. So that's why I'm putting parentheses, subtract. 3x to the 4th minus 3x to the 4th is 0. Nothing. That's supposed to happen. You could say it's 0x to the 4th, but that's not necessary. 0 minus negative 6x cubed is really like 0 plus 6x cubed. So this is going to be plus 6x cubed. And I really don't recommend writing the 0 thing. That should always happen, that cancels with that. So I'm going to erase this because it's getting confusing. Okay. And of course, it's not letting me erase it. Whatever. Okay. Now, I bring it down. Minus 8x squared. Basically, you're just repeating the process from here forward. So you're saying, what times x gets me 6x cubed? 6x squared. So, is it positive or negative 6x squared? Positive. So I'm saying 6x squared times x gets me that I wanted. Now I also have to do this, though. So 6x squared times x is going to get me the 6x cubed. But I also have to do 6x squared times negative 2, and that's going to go right here. So 6x squared times negative 2 is negative 12x squared. Parenthesize, subtract. As soon as you finish that distribution, parenthesize, subtract. So this 6x cubed minus 6x cubed goes away. That should always happen. If that didn't happen, you didn't choose the right thing up at the top. Negative 8x squared minus negative 12x squared really makes negative 8 plus 12, which is 4x squared. Bring down minus 11x. Okay, so here we are again. What times x gets me 4x squared? 4x. But I also have to do times the negative 2. So 4x times x gets me the 4x squared I wanted. But 4x times negative 2 is going to get me negative 8x. Parenthesize, subtract. Four x squared minus 4x squared goes away. That should happen. However, negative 11 minus negative 8 really is negative 11 plus 8 is negative 3x. Last one, bring down the 1. You keep bringing it down until you cannot bring it down any further. Okay, so what times x is negative 3x? Just negative 3. So negative 3 times x gets me that negative 3x. But negative 3 times negative 2 is positive 6. Parenthesize, subtract. This cancels. 1 minus 6 is negative 5. That is your remainder. So this is your final answer. There's no reason why that 3x cubed is blue. I just changed colors in the middle of my problem. Any questions? That's okay? All right. So let's do another one. All right, so this one you're going to have to set up yourself. Remember, I forgot to say this, but you do need to check your degrees. So let's check the degree on the top. Degree of 3, then it goes to 2, then it goes to 1, then it goes to 0. That one's okay. So I will just put that on the inside as is. So 6x cubed minus 4x squared plus 3x minus 2. However, it is going to be the divisor or denominator that has a problem because it starts with a degree of 2 and then it jumps to the number. So what's missing is the 0x. So I'm going to use 2x squared plus 0x plus 1. So that goes on the outside. 2x squared plus 0x plus 1. All right, and then we basically will start. Let's parenthesize this just so we make sure we distribute everything. Your focus is on the 2x squared. So what times 2x squared is 6x cubed? 3x. So 3x is going to go first. So 3x times 2x squared is the 6x cubed we wanted. 3x times 0x. 3 times 0 is 0. X times x is x squared. I do recommend writing the 0 and the x squared. I realize it doesn't make a difference, but think about those nice pretty rows that are lining up so that you know you're subtracting like terms, okay? All right, we also have to do 3x times 1, which is plus 3x. Parenthesize, subtract. So 6x cubed minus 6x cubed, that goes away, as it should always. Negative 4x squared minus 0x squared. Negative 4 minus 0 is still negative 4. X squared. 3x minus 3x is 0x. It does cancel. Let's go ahead and continue to write the 0. And we will bring down the 2, or negative 2, I should say. All right, one more. So what times 2x squared is negative 4x squared? Negative 2. So negative 2 times 2x squared gets me the negative 4x squared I wanted. But negative 2 times 0x is, you could say negative 0x or positive 0x, really doesn't matter. Negative 2 times 1 is negative 2. Parenthesize, subtract. Almost done. So what happens is negative 4 minus negative 4 cancels as it should. 0 minus 0 cancels as it, that shouldn't happen. But it does happen. It's not that it shouldn't happen. It's just that that's not an always thing. I'm just going to stop talking. Y'all know what I'm doing, right? Let's just say that. Negative 2 minus negative 2 also cancel. So is there a remainder?
No.
No. So you really don't have to write your remainder 0. This is your final answer.
Was that like a harder one, or was that like an easier one?
Honestly, I prefer long division. And while this seems like it's going to be harder because there's more, it ends up being easier because I think we should take the time to think about what's happening. If you do 15 divided by 3, you get 5, right? So what that means is that 3 times 5 is 15, obviously. So what this is doing is that it's saying that if you multiply this times this, you should get all of this. So it makes sense that this is a smaller degree because 2x squared times 3x, the x squared times the x is how you're going to get the x cubed. So if this degree is bigger, this degree is smaller, which in turn actually makes it easier. We are going to practice dividing and then multiplying to check our answer, but I thought it was too much to do in one day, so we're not doing it today. Okay? All right, let's go on. If synthetic confuses you, you can go to this website, www.purplemath.com, module synthetic division, and they can do some examples. Yeah.
Do you want us to write remainder 0?
I don't care. It's going to become really important in like 4 days. But not that you write it or don't write it, just that you understand what a remainder is.
Okay.
And I think that we should practice forming this thing. So cross this off and pretend like you never saw it. Because we need to practice it. This one too. And I'm going to make this bigger on my thing again. Okay. Once again, as I introduce synthetic division, it is a process. I cannot tell you how or why it works. It is a shortcut to long division, and keep in mind it only works when the divisor is of degree 1. So first we check x minus 2, that's x to the first power, so this is a category in which it would work. While we're checking stuff, let's check the quotient, the other thing. I have a 4th degree, then I have a 2nd degree, 1st degree, and no degree. So I need to insert plus 0x cubed here. Just like you did for long division. We're still going to do that. All right, so we start the process with a box, a line, and that's it. So what goes here is the divisor solved. So when I say solved, I mean solved for 0. So we're going to say x minus 2 equals 0, so x equals 2. We are going to put a 2 right here. If you want to just think it's the opposite sign, you can, but I really suggest doing this. Because let's say this had been 3x minus 2, then it would have been 2/3. Not that that comes up that often, but when it does, you need to be able to understand that. Okay, what goes right here on the other side are your coefficients of the quotients. Quotient is the thing that's being divided. Divisor is the thing doing the dividing. And this is going to include the 0 that we're going to insert. All right, so we're going to start with the coefficient of 3, because that's attached to the highest degree. Then we're going to go to the 0, because that's the next. -8, -11, and +1. Okay? All right. You start just by pulling down the 3. It's just how we always start. Now what I have said is multiply diagonally, add vertically. So 2 times 3, that's a diagonal movement. 2 times 3 is 6. But 0 plus 6, this is a vertical movement, is 6. Now I got to do it again. 2 times 6, that's a diagonal movement. 2 times 6 is 12. -8 plus 12 is 4. 2 times 4, that's another diagonal, so this is multiplying. 2 times 4 is 8. But I add vertically, -3 plus 8. I'm sorry, -11 plus 8 is -3. 2 times -3 is -6. 1 plus -6 is -5. Okay, that's your answer. Let's do the order. Right for remainder. This is really convenient for you because it's on the right side. So you're going to put an R. You can remember by saying it's the right side, but really it stands for the remainder. Then you go up in increasing order. So then would come the number, then the x term, the x squared term, the x cubed term. It is much easier. Why it works, nobody knows. But it is much easier. So 3x cubed plus 6x squared plus 4x. This is negative, so this will be minus 3, remainder 5. Sorry, I should have boxed that remainder 5. I just write big. Remainder negative 5. Thank you. So if you look, I don't know if I still have mine. Oh, and I do. If you look at the difference between the two answers, there shouldn't be one. Remember I said that this question is the same as this question. They're just showing long division. It is long. Synthetic division, much shorter. Same answer.
Oh, wait, it's
Okay? All right, let's do it again. Somebody actually watches this. I apologize because you're probably getting really dizzy. That's okay, though. I'll watch it tonight. Make myself feel good. I'll have 30 views. Okay, let's set up. We have a box. We have a line. What goes in the box is the divisor solved. So x plus 3 equals 0 is negative 3. What goes all of the way across here is your coefficients. Before you start writing, let's check the coefficients. X to the 5th, 4th, 3rd, 2nd, 1st, none. So everything's there. We're just going to fill in the coefficients. 1, 5, 6, negative 1, positive 4, and 29. Always start with an arrow, just pulling down the 1. So, negative 3 times 1, that's a diagonal movement. So, negative 3 times 1 is negative 3, but this is a vertical movement. 5 plus negative 3 is 2. Negative 3 times 2 is negative 6. 6 plus negative 6 is 0. Negative 3 times 0 is 0. Negative 1 plus 0 is negative 1. Negative 3 times negative 1 is positive 3. 4 plus 3 is 7. Negative 21 is 8. Write for remainder. Then the regular number, x, x squared, x cubed, x to the 4th. So a final answer is 1x to the 4th, or just x to the 4th is fine, plus 2x cubed. If you want to write plus 0x squared, I think that's fine, but if you don't, that's fine as well. Minus x plus 7, remainder 8. Okay. All right, on tonight's homework, they have 3 problems that require you to do long division. That's the harder one, the longer one up here. I am just going to say do at least 1 long division on your homework, and I would be happy. I realize this is y'all's preferred method, and quite honestly, we will use this a lot more. Okay? Before I start, if I were to ask you what's 1,273 divided by 11? Okay, without a calculator. We do 11 on the outside, 1,273 on the inside. So you say, does 11 go into 1? No. So does 11 go into 12?
Yes, one time.
One time. 1 times 11 is 11. Subtract. You get 1, bring down the 7. How many times does 11 go into 17? 1 times 11 is 11. Subtract 6. Bring down the 3. Does 11 go into 60? Or how many times does 11 go into 63? 5. 5 times 11 is 55. Subtract. And you get a remainder of 8. When you first initially learned this, they would say, well, put a point there and keep going until it stops. That's good for numbers, not for polynomials. So we will just say remainder blank. Okay? Just as a quick reminder of what dividing is. All right, let's go back.